Hi everyone, this is Mrs. Rondo. We're going to be talking about sequences and formulas, and sometimes we call those formulas rules. So you're going to see the word rules a little more often, but they act just like formulas. Our essential question: how do we use explicit and recursive rules to evaluate sequences? And our learning target: I can apply a rule for an arithmetic sequence to find the terms of a sequence. So before we go too far, definitely want to take a minute, maybe pause the video and write these key terms down. A sequence is a list of numbers that follows a specific pattern. So for an example, here is a sequence. Dot, dot, dot. So here my pattern was adding 4 to each term. So I started with 3 and I just kept adding 4. All right, so that's just a quick example. And then domain, we've talked about domain before. Remember, domain means X values. In this case, when we're talking about sequences, it's the position number of the terms of a sequence, and I'll explain that more in just a second. Then we have range, which remember is Y values. And the Y values, when we're talking about sequences, are the actual terms of the sequence. Okay, so we have the sequence that I gave as an example: 3, 7, 11, 15, 19, dot, dot, dot. So these are the actual terms of the sequence, which we call the range. Okay, and then we have the number of the term, also referred to as the position, and we call these values the domain. So what that looks like is the first term, or what we would represent with the number 1. So the number 1, the first term is 3, the second term is 7, the third term is 11, the fourth term is 15, the fifth term is 19. So that's kind of how it works. So there's kind of two sets of numbers going on. The domain, we're talking about which term in the sequence. Is it the first one, the second one, the third one, and so forth? And the range is the actual sequence. So hopefully that kind of helps clarify. Let's continue forward. All right, so we're going to write out the first 4 terms of the sequence defined by these explicit rules. So this is function notation, which you may have forgotten, but we're going to practice it. This notation, basically, it's f of n, not f times n. And the n basically represents the variable that we're going to plug in for. If we want the first 4 terms, that means the numbers we're going to plug in are 1, 2, 3, and 4. 1 will give us the first term, 2 will give us the second term, 3 will give us the third term, and 4 will give us the fourth term. So here we go. F of 1, that means I replace all the n's with 1's and I solve. So this one, I get 1 squared is 1 plus 2 gives me an answer of 3. Then I plug in 2 and I replace all the n's with 2's. And I get 2 squared is 4 plus 2. 4 plus 2 is 6. There's my second term. Then I plug in 3. All the n's become 3's. 3 squared gives me 9, plus 2 is 11. My last one, I plug in 4. And I get 4 squared is 16 plus 2. I'm going to sneak it in here, is going to be 18. So the first 4 terms of my sequence are 3, 6, 9, 11, and 18. So there we go. That was a little weird. 1 squared, 2 squared. Sorry, just for a second. Hold on. All right, so let's try the next one. Same basic idea. We want the first 4 terms, so we're going to plug in for n 1, 2, 3, and 4. So here we go. Plug in 1. So I get 5 times 1 minus 7 I get 5 minus 7, which is -2. Then I plug in 2, so replace all the ends with 2's, and then I solve. 5 times 2 is 10, minus 7 gives me 3. Then I do plug in 3. 5 times 3 minus 7, I get 15 minus 7, which is 8. And finally, 5 times 4 minus 7, I get 20 minus 7. Oopsie, sorry. Go back real quick. And that gives me 13. So this one, the first, how did I get? Oh, there we go. That's what's wrong. I'm so sorry, guys. I knew something looked funny on that first one. I don't know where I got the 9 from. I apologize. Dear heavens. Sorry, I get carried away here. First 4 terms of the sequence, let me just double check, was 1, 2, 3, and 4. My apologies there. I just got a little carried away. And then if we check them on this one, it's 2, 3, sorry, -2, 3, 8, and 13. So that would be -2, 3, 8, and 13. All right, there we go. All right, so then this next slide here, we're using the same sequences, but this time we're going to find the 20th term of each sequence. And so here's the key. If I want to know the 20th term, what number do I plug in? I plug in 20. If I want the 20th term, I'm plugging in 20. All right, so I'm going to go ahead and do that. So I get 20 squared plus 2. This looks delightful. But actually 20 squared is not too bad. That's going to give me 400 plus 2. I get 402 or 402. So I have kind of skipped writing the f of 20 or the f of whatever, but this should really be f of 20 every single time. So this tells me the 20th term is 402. All right, let's look at this one. We're going to go ahead and plug in 20. And so 5 times 20 gives me 100 minus 7, and I get 93. And again, if I copy this through, this tells me the 20th term is 93. Okie dokes. So these I didn't specify, or I didn't draw a lot of attention to it, but in the directions we had this phrase of the explicit rule. So explicit rules are just rules where we can plug right into the formula, but we're going to see a new kind of rule in the next slide. If we look at the directions, find the first 5 terms using recursive rules. So recursive, the difference is that recursive requires us to go back to the previous term. So you always have to be given what term to start with. So notice this says f of 1. So the first term is 4. And this one says f of 1. The first term is 37. So don't let the notation scare you. It looks a little crazy, but we're just going to go with it. So we already know the first term. So it says find the first 5. We already know the first term is 4. So I'm going to go ahead and start by finding the second term. So that means I plug in 2. So we are going to be plugging in 2, 3, 4, and 5. And again, that's because we already have the first term. So I plug in 2. That means all the ends become 2's. And then I'm going to simplify in parentheses there. 2 minus 1 is going to give me f of 1. And here's where we get to do some fancy substitution. Right here, I have f of 1. But I also have it right here. I know f of 1 is equal to 4. So I'm going to replace my f of 1 with what it equals, which is 4. And when I do that, I get 4 plus 10 is 14. And I'm going to scooch this a little bit. Sorry, hold the phone, just because we got to do this a couple more times. There we go, 14. All right, so then I'm going to go ahead and do that with the next term. I'm going to do f of 3, and I just plug in all the n's, become 3's. And so this one, I'm going to do f of 3 minus 1 gives me 2, and then plus 10. Remember, this f of 2 means the second term, or we saw it back here if I kept writing down f of 2, this equals 14. So I already know that f of 2 is 14. So I'm going to use that instead of f of 2. So hopefully we're starting to see kind of the pattern that we use here with recursive rules. It's how recursive rules work. Okay, so whoopsie, I want to do this with red. Okay. So this would be 14 plus 10, which is 24. And there's my actually third term. Remember, my first term was back at the top. It was given to me, excuse me, as the 4. So I have 4, 14, 24. You should be able to start seeing a pattern here, but we're going to go ahead and continue using the rule because that's what we're working. Our focus today is practicing using the rule. So now I'm going to do f of 4, which means all my n's become 4's. And I'm going to simplify. 4 minus 1 is 3. And so once again, I'm going to say, hey, wait a minute. I know f of 3 is the same as 24. Because remember, it would have been right here if I kept writing f of 3, it was 24. So I'm going to plug in 24 plus 10, and I get 34. And then my last one here, I'm going to do f of 5. So all the, excuse me, all the n's become 5's. And so I get f of 5 minus 1. 5 minus 1 would be 4. And then plus 10. And one more time, we get to see that pattern where the f of 4, I know what that is. I saw it in the last part here is the previous term. So again, if I kept writing this down, f of 4, I would have said, oh, look, it's 34. So I'm going to kind of squish it down here. My f of 5 is going to equal 34. Remember, that's just a replacement of this right here, f of 4. And then I add 10, which gives me 44. So the first 5 terms of my sequence are 4, the 4 that was given, 14, 24, 34, and 44. All right, so it does take a bit of work, but it is a very consistent pattern. We're going to try it with this next one. So again, we want to find the first 5 terms. Remember, they gave us the first term is 37. And so we are going to plug in the remaining 2, 3, 4, and 5 to find terms 2, 3, 4, and 5. So I'm going to start with 2, and I make all the n's 2's. Then I'm going to simplify. F of 2 minus 1, that's really 1. And here's where we get to see that wonderfulness. F of 1, we know what that is. That is the 37. So we're going to replace f of 1 with what it equals, which is 37. 37. All right, so I would have, this time I'm going to write it to kind of help us out. F of 2 would be 37 minus 3, which is 34. All right, so now I go to my next term, f of 3. And all the n's become 3's. And I subtract. So I get 3 minus 1 is 2. And I know f of 2 is 34. And so then I would subtract. Remember, I am pulling that f of 2 from my previous problem, which was right up there. So I'm saying instead of f of 2, I'm going to write what it equals, which was 34. And then 34 minus 3 is 31. All right, then I go on to the next one. Plug in 4. All the n's become 4s. And I simplify. 4 minus 1 is 3. I'm having trouble writing my 3. All right, and then once again, I know what f of 3 is. We saw it just a moment ago. We found that f of 3 was 31. So I'm going to replace f of 3 with 31. And then I'm going to subtract 3, which gives me 28. Cool. Then I'm on my last one, my fifth term, and all the n's become 5s. And so I have f of 4, because 5 minus 1 is 4, minus 3. And again, we know what that f of 4 is. We just saw it a moment ago. Not the eraser, whoopsie. And so I'm going to replace f of 4 with what it equals, which is 28. Subtract the 3, and I get my final term is 25. So my 5 terms, starting with the one they gave me, I'm going to sneak it up here at the top. I'm kind of out of room. I have 37, 34, 31, 28, and 25. So there we go. All right. Then in a similar fashion, we're going to do, like we did a moment ago, find the 20th term for each sequence defined by a recursive rule. In order to find the 20th term when we're doing recursive, we must know the term before. So notice I gave us the 19th term for each for each sequence so that we would be able to find the 20th. So if I want to find the 20th, I plug in 20. So I'm going to do f of 20 equals f of 20 minus 1 plus 10. And when I simplify, 20 minus 1 is 19. And here's where we get to see that previous f of 19, which is what they gave us up here at the top. So I'm going to plug in, instead of f of 19, I'm going to plug in what it equals, which is 184. And then I'm going to add 10. And I find that the 20th term is 194. So that's how I would write it in function notation, or if I wrote it out, I would say the 20th term is 194. All right, and then the next one, same idea here. We're going to plug in 20 for n, which means all the n's become 20. And then I'm going to simplify. 20 minus 1 gives me 19. And once again, I look back and they gave me f of 19, which is right here at the top. So I'm going to substitute instead of f of 19. I'm going to put in what it equals, which is negative 14. And then that allows me to get f of 20. Final answer is negative 17. And again, if I wanted to say it in words, I would say the 20th term is negative 17. All right, one last type of problem. And by the way, these problems match your practice assignment pretty much exactly what I'm asking you to do to practice. But the last one says, find the position number, the domain of the given term for each sequence. So we're back to explicit rules because we don't have the first term given here. It says which term in the sequence is 64. So this is a little bit different how we handle this. The f of n, this whole thing represents the whole thing represents the term. The n itself represents the number of the term. So it's a little weird. So if I want to know what term in the sequence is 64, I'm going to make 64, I'm going to replace the f of n with 64. And then I'm going to solve for n, which is going to tell me the number of the term. So it's a little weird the way that we write it, but this is how we find it. So if I solve this, I would start by adding 4 to both sides. So I get 68 equals 2n, then divide both sides by 2, and I get 34 equals n. So then my answer would be 64 is the 34th term. So there you go. So we're going to practice it again. Last example here. So again, if we want to know which term in the sequence is the negative 28, then I'm going to replace f of n with the negative 28. And I'm going to solve for n, which is going to tell me which term. So again, remember that n is telling us the number of the term. It's telling me which term in the sequence. Okay, so then I would simplify, or not simplify, excuse me. I want to solve for n. So I need to get rid of, I have that negative 5 and the 2. I'm going to start by subtracting 2 from both sides. And that gives me negative 30 equals negative 5n. Divide both sides by negative 5. And we get 6 equals n. So we can say negative 28 is the 6th term. And there you have it. Awesome. Check Google Classroom for your assignment and have a great day.